Hi guys, today I'm going to be showing you how to count the colonies that you got from your serial dilution. So in front of us we just have one of the plates that we plated yesterday using our serial dilution technique. We spotted 10 microliters from each well of our 10-fold serial dilution. And now if you look closely, you can see that from the top, as we go down, our colony fields become less and less dense until we eventually get to just a couple of colonies and then eventually 0 colonies. So what I've done is that I've just counted the countable colonies. So you can see here I have 5, 4, 7, this one's 0, and then 10 above it. Here's 5. Unfortunately the focus isn't that good here. And so I have a number for each dilution that's countable, and that corresponds to a column. So each one of these columns is a sample. So I have sample, let's see, 3, 12, 2, 12, 1, 12. Over here we have 1, 0, 2, 0, and 3, 0. And if we were to look down the row at, sample 3, 3, which is right here, I think. No, it's right there. We're going to get 1, and that is at a dilution of 10 to the minus 8th, or rather 10 to the minus 10th. So that says that, okay, well, we have one colony at a 10 to the minus 10th dilution, so all we have to do is multiply that number by 10 to the 10th, and that tells us that we have 10 to the 10th cells per milliliter in our original culture. So that's kind of the working principle. You just count the countable colonies, and then you multiply, or you count the colonies at whatever dilution factor is countable, and then you multiply that number by the dilution factor, and that gives you the original number of bacteria in your culture per milliliter. So just wanted to give you a brief kind of colony counting tutorial. Generally you want to be able to count around 25-ish is a good number. I usually just count between 1 and 30 or 40, and I just count multiple dilutions if I can, and then just either pick the best number, or if I'm confident in 2 numbers, then I'll just average them out or something like that. But I'm always about more data. So a couple other quick notes. I'll try to zoom in on this one. The focus is going to get bad, but you can see right here that what should be 2 dots is actually 1 dot. That's because when I plated this, or when I squirted the liquid out of the pipette, the multi-channel, the little liquid bulbs kind of merged together, and it's kind of like the opposite of a cell division, and that means that the colony populations, or the bacterial populations in each one of these equalized, so that's a lost data point. We have a couple more examples of that. There's one there, right there, and then another there, and another there. So luckily those are high dilutions, and I wouldn't have been able to count those anyways, but just be aware of that. Now if that had happened down here, I hope it didn't, it would also make it very, very difficult to count. So it looks like we had one there, but when the colonies are too far apart, it's going to be very difficult to tell if that actually happened. But you can just kind of look at the general pattern of things in order to kind of QC it. So this dilution looks like it's about 100 or 10-fold more than this dilution, etc., etc., and 100 times more than that. So that's how you can titer a culture using serial dilutions and plating out those dilutions and counting the colonies on them, and then calculating the colony forming units per milliliter.